Welcome back, students. This is the Q&A session 20 from the playlist of work, power and energy. The topic is the heat produced by an impact. So based on this topic, I have selected one question which is available in the NCERT book. The question here is: a bullet of mass 0.012 kg strikes a wooden block of 0.4 kg horizontally with a speed of 70 meter per second. The bullet comes to rest instantly in the block. The block is suspended from the ceiling by a thin wire. To calculate the height to which the block will rise and the amount of heat produced in the block. So I have already drawn here one figure based on this question. And in this question, this is the wooden block which is hung from the ceiling with the help of this thin wire. And a bullet strikes this wooden block horizontally with a speed of 70 meter per second. Now, in this question, it is written that the bullet comes to rest instantly in the block. That is, when it strikes the wooden block, it comes to rest in the wooden block instantly. And now, here we have to find the height to which this block will rise after this bullet strikes this wooden block and gets embedded into it. So, in order to find the height to which the block will rise, we will use the law of conservation of momentum. So as per the law of conservation of momentum, the total momentum of this wooden block and the bullet before the impact should be equal to the total momentum of this wooden block, which now contains the embedded bullet, because the bullet has entered this wooden block and it has also come to rest instantly. So the initial momentum of the bullet is equal to 0.012. This is the mass into velocity, which is equal to 70, and the initial momentum of this wooden block is 0 because it is stationary. Its velocity, or you can say the speed, is 0, and this is equal to the v dash. V dash is the velocity of this wooden block after the impact multiplied by the total mass. The total mass will be equal to the mass of the block, which is equal to 0.4, plus the mass of the embedded bullet. So V dash from here will be equal to 0.84 divided by 0.012. So this is equal to 2.04 approximately, 2.04 meter per second. So the velocity of the wooden block after the impact, velocity of the wooden block after the impact, this is equal to 2.04 meter per second. Now, after the impact, this wooden block will get some kinetic energy because of this velocity. So, the kinetic energy of the block after the impact this will be equal to 1 by 2 the mass of this wooden block. Now the mass of the wooden block will be equal to 0.4 plus the mass of the bullet which is embedded in it into V dash whole square. So this is the value of the kinetic energy of the wooden block after the impact, and this value will be equal to 1 by 2 into 0.412 into V dash square, so which is equal to 2.04 whole square. So this is equal to into 2.04 into 2.04 into 0.412. divided by 2. So this comes out to be just wait, 2.04 into 2.04, yes, into 0.412 divided by 2, which is equal to 0.857 joules. So the kinetic energy of this wooden block after the impact will be equal to 0.857 joules. Now, this wooden block will move as shown by this dotted line. That is, this because of this kinetic energy, this block will move in this direction. It will move in this direction and it will attain a certain maximum height. Now at the maximum height, this kinetic energy will completely get converted into the potential energy. So by the law of conservation of energy, this kinetic energy will be getting converted into the potential energy, and this will be equal to mgh, that is the mass of this wooden block, into g into the h, that is the height attained by this block, and this will be equal to 0.857. So from here, the value of the height to which the block will rise will be equal to 0.857 divided by the mass, which is equal to, now here the mass will be equal to the mass of the wooden block plus the mass of the bullet. So this is equal to 0.412 into g. G, if I am taking the value of g as 10, so h will be equal to this value, and this will be equal to 0.857 divided by 4.12. This is equal to 0.208 meters. This is equal to 0.208 meters. Or you can say the maximum height to which this block will rise. This will be equal to, if I write it in centimeters, then it will be approximately equal to 20.8 centimeter. So the height to which this block will rise will be equal to 20.8 centimeter. Now we have to find the heat produced in the block. Now the heat produced in the block, this will be equal to the change in the kinetic energy. Now the change in the kinetic energy, so this will be equal to, the initial kinetic energy will be equal to the kinetic energy of this block plus the kinetic energy of the bullet. So the kinetic energy of the bullet will be equal to half into m is equal to 0.012 into v square, which is equal to 70 whole square. Now the kinetic energy of this block is, in the initial kinetic energy of this wooden block before the impact is equal to 0. So the change in the kinetic energy will be equal to the initial kinetic energy. So this is the value of the initial kinetic energy minus the value of the kinetic energy after the impact, which is equal to half into the mass of this wooden block, including the mass of the bullet. So this will be equal to 0.4 plus 0.12, so this is equal to 0.412 into the speed of this wooden block after the impact. So this is equal to 2.04 whole square. So this is equal to, so this will be equal to 70 whole square, this is equal to 4900 into 0.412 divided by 2. Sorry, this is equal to 2.04 into 2.04 into 0.412, that is equal to 0.857. So this is equal to 0.857 minus, sorry, I'm making some mistake. This is equal to 49, sorry, 4900 into 012 divided by 2. This is equal to 29. The value of this initial kinetic energy is equal to 29.4, and the value of this one this is equal to 2.04 into 2.04 into 0.412 divided by 2. This is equal to minus 0.857. So this is equal to 29.4 minus 0.857. 0.857. So this is equal to 28.5. This is approximately equal to 28.5 joules. So the amount of heat which is produced in the block will be equal to 28.5 joules, because the amount of heat produced is equal to the change in the kinetic energy. And the change in the kinetic energy is equal to the initial kinetic energy minus the kinetic energy after the impact. So thank you very much for joining this session. In the next session, I will be taking up a different type of a question from the same chapter, that is work, power and energy. So till then, have a nice day. Bye.